Okay, this is a test of a screencast, so be sure to let me know what you think and if this is useful or a useful way to make up if you're one of the students who can't come to my review sessions. So we're just going to go over what I went over with the other students on Friday, namely talking about classes, inheritance, and templates. So if you do have any questions, you're welcome to email me at any point during this, and I'll try to find a good forum for us to use that I'll note somewhere in the notes. All right. So go ahead and get started. You'll note I've got, so I have Genie open in the VirtualBox. You don't have to use Genie. If you don't want to, you're welcome to use whatever your text editor of choice is. But because the department has been using Genie in different classes, that's what I'm going to use here. With this video, you should have found some starter files, and you're going to want the inheritance starter files for this. So you should have a make file, a person.h, a person.cxx, a student.h, and a student.cxx, as well as a student example. One thing I will note, one question I've been getting a lot is, what is this .cxx thing that you're using? How come you don't use, let me see if I can highlight that. How come you don't use .cpp? And the answer is pretty simple. That's just what I learned with, so that's what I use. There's really no right or wrong file type for you to use for this. So I'll just go over the files real quick. The make file is just going to help us with our compilation. If you want to learn more about those, there's plenty of tutorials on the internet, and they're kind of boring, so we're going to skip it. The only thing you really need to know is that if you just use Genie's default build, things aren't going to compile properly, so you want to make sure you choose make all the first time you run that. And if you are having any trouble with compilation, oops, wrong button, you can say make clean here, and it will clean up all your files so you can get a fresh compile, and sometimes that can be useful. So I'm going to go ahead and close that. I don't need to have it open, but I do want to make sure it's in the same file where all my other files are. One easy way to do that is to use the terminal and just type ls to list things out. You can also use Genie's version of File Explorer. So here I have the person class. This is a very simple version of people. Obviously, people have more attributes than what we have here. So you'll see I'm declaring a class called person. And then I have some protected variables. I'll get into why those are protected a little bit later. But for now, know that people have names, ages, a weight, and a gender. And obviously, again, people have more attributes than that, but we're doing a very simple person. And then for my public methods, you'll find my explicit constructor that takes a name and a gender, a method called talk that lets my person talk in some form and takes a sentence as an argument, and a toString method, which I always like to have in general for all of my methods. For all of my classes. In person, I define those. This is kind of a dumb constructor. It takes the name and the gender and assigns those to those class variables that we had over here. And then I just fill in some random values for age and weight. Because this example is intended to teach you about inheritance, not to teach you about how to make a perfect representation of a person as a C++ class. Next, you'll find my talk method, and what that does is just take the sentence and write it to the standard output stream. So just write it to cout, to our console. I could make this a much more complicated method or write to different output streams, but this is a really simple example just to have a fun, different sort of method for our person to use. And then my toString method just returns the name of the person. I could add more of my attributes or things like that to the string if I wanted to, but for now I'm just going to use the name and keep it super simple. So we're going to hop over to student example, and you'll note that I've chosen to include person.h and student.h and IOStream, just so we can see some of what we're doing. Right now, I haven't changed student.h or student.cxx from the files that you have in your starter pack. So now I'm going to say person Fred, and I'm going to go ahead and say his full name is Fred Jones. So here's just my simple use of that explicit constructor. I don't have a default constructor in my person.h, and you can debate the wisdom of that or not. In my case, I don't really think we have default versions of people, so it makes sense to force my users to use this explicit constructor. And then I'm just going to go ahead and say, take the person Fred and turn him into a string. So Fred.toString, and you'll see Genie pops up that autocomplete. And I'm going to go ahead and make all. One problem. Let's see what error came up. So here it's saying no matching call for const character of length 11. And so what you'll notice here is I've actually called my own constructor incorrectly because I was rushing a bit. So you'll see here I'm expecting 2 variables, 2 arguments, and if we go to my example, you'll note I only gave it 1. So I better go ahead and add in that extra bit. And when I compile, you'll see it's all nice and clean. And when I run, I get that output. So again, a super simple person class. Not much to see here. If I use talk, Fred talk, let Fred say hello world. And then when we run that, so again, make sure you make. You'll see I get that make command down here. I don't want to build, or I get all kinds of rumpus. So again, make sure you get that make command. And when I run, we get Fred talking. So now we're going to take a look at the student.h file, and you'll see that it's relatively simple. What's important here is I'm telling my compiler, okay, I'm making a new class called student, but it inherits from person. So what this statement is saying is students are people. This is what we call inheritance. It's also what we call polymorphism. Students are people, but they're also students. So they're going to have some attributes that other people don't have. For example, in this case, a student ID. I'm choosing to make that a string because I'm not going to be doing any math with a student's ID. I'm not going to say like Bob's ID plus student's B's ID equals whatever. That doesn't make sense. So if I'm not going to be treating this number mathematically, it just makes more sense to store it as a string. And then I'm going to say, well, what's another thing students have that others don't have? They have classes. So maybe I would say something like string, make a vector of strings. So I'm going to say vector string classes. So you'll note up here that I've already got that vector imported, but I want you to remember, and this will come in handy later when we talk about templates, that a vector isn't a complete type on its own. We don't just have a vector, although that's often how you'll hear us refer to it in lecture. Instead, you're going to have a vector of strings or a vector of ints. So you have a vector of something. In this case, we have a vector of strings that represents the names of the classes our student has. Then down here, you'll see my student constructor takes a name, a gender, and an ID. Now, I haven't explicitly declared a class variable call to store the name or the gender for the student, but our student inherits all of these different attributes. So student has all of these as well as an ID and a string, a vector of strings for classes. All right, so that's about it for the header file. We're going to hop over here, and you'll see I have absolutely nothing in my student.cxx file except for some includes that I'll be using later. So what I want to do now is say, okay, I need to make my constructor. I need to create that constructor. So what I'm going to do is actually just copy the method signature here just to make sure I get it exactly the same. That's a personal preference. You don't actually need to have the same names for your parameters in the header file that you do in the main file, but it's just easier for me to keep track of things, and it helps me keep all of my code organized, so that's what I prefer. So now the first thing I want to do is get rid of that semicolon. I don't want to keep that there, and add in my curly brackets. The next thing I'll do is remind it, hey, I'm defining things in the student class. So just like that, I've got my method definition skeleton all set up. The other thing I need to do, because I'm inheriting from this person class, as I've said up here, is to let it know, hey, I want you to call the person class. and you'll see it pops up that person definition right there. And I want to say, I want to call it with some name and some gender, those parameters I passed in. So what this lets me do is say, all right, the part of the student that is a person, the part of a student that's the same as a person in definition, so all of these parts, go ahead and just use the person constructor to define that. You don't need, let me see if I can stretch this to make it a little bigger so we can see that whole method. You don't need to redefine any aspects of those. The only thing I do need to do is say, okay, and my ID equals new ID. Some of you may be wondering why I haven't done anything with the vector other than what I have here. The vector is already set up, so I could add something that would let me add a class for my student, and we'll do that in a minute. So now, and in fact right now, so now we're going to say, okay, void add class for the student with a string for the name of the class. So just a simple method to add classes, because if you don't have any classes, you kind of stop being a student. So go ahead and copy that and hop over to student again. Make sure I'm outside of that constructor. And the same general methods apply. So again, get rid of that semicolon at the end and add in the label letting the compiler know, hey, I'm working with the student class. And this is going to be very simple. I'm not going to check and see if they're already enrolled in a class. If they choose to say, I want to add this class, we're just going to let it go through. So we're going to say classes, and I'm going to use the pushback method just to add a class because I'm not worried about the order of my classes or anything like that. I'm just going to say add this to the classes for the students. So we'll go ahead and make. Oh, and then, so the important thing if you are using Genie and not doing this from command line is you want to make sure you're actually in the student example file, that one, wherever you have your main file before you run. Or it will happily try to run a file that doesn't exist. So I compiled and ran because that's how I check and make sure that all of my code is working and that I haven't broken anything on the way. So I ran what I knew worked first. Now I'm going to say, okay, I need a student. She's going to be Susan. She's female. And I'm going to say her ID is 1, 2, 3, 4, 5. And then I'm going to say, okay, Susan dot add class, and we'll say English Lit. And we'll go ahead and run and just see if we've broken anything. Again, it's really important to check, and you'll note we have no output here, but nothing crashed and nothing broke, so we have a pretty good idea that some of our stuff is working. One thing I will caution you is that don't assume that just because this all went through that everything is working perfectly. You do want to explicitly test and make sure that your classes are being added. So we might want to write a specific student to string, for example. But that maybe it would look something like string student to string and maybe we would do something like this. So this is, I haven't put a lot of thought into this, this is just kind of an example of what might work. So we might say something like string version and start with an empty string. And I'll just state here that this is a little bit of an abuse of strings, and there may be better ways to do this, but for the purposes of this exercise, we're going to do it this way. So we're going to say that the string version starts with her name, and then says, maybe we'll say, is enrolled in the following classes. And then we want to go through everything in our vector and add it. So that's going to look something like this. So just a quick for loop. Going through everything in the class. and saying, oops, I forgot concatenation up here. Some of you are probably yelling at your screen, letting me know that, but don't worry, I fixed it. So make sure you actually concatenate when you're putting things together, that you make sure that the different parts of strings are added to each other. And then down here, I'm just going to say string version equals the existing string version plus, and then whatever the class happens to be. So classes at index. And then the last thing I want to do is make sure I return the string version of my student. Now here I'm going to make, because I'm imperfect, and you'll see I get an error that says no toString member function declared in this class. And that's a good point to go, hey, wait a minute. You said that all of these variables I didn't have to redeclare because student knew about them. What's up with string? It's declared. So the thing that happens here is what happens in the header files. We're using the versions of those variables that we inherit. Whereas here, we can't just overwrite that toString. We need to say explicitly, hey, I want a toString in my student.h. So at this point is where you'd want to add string toString to your student.h file. Even though it is already in that person.h, we have to add it again just to let it know that we want an explicit student toString method. Okay, and then I forgot to save this file. So it's letting me know there's a comparison between unsigned ints, and it's actually a good practice here that I just didn't think about because I was in a rush, to use a type of unsigned int when you're comparing to size. You can't have a negative index in that vector. Okay, so there was a brief problem in the previous set where I realized belatedly I lost a sound in my microphone a couple times. So I know there's at least one other section where that got lost, but I haven't listened to the entire cast to find out. So if you do find that and you have questions, just go ahead and ping me, send me an email, and I'll try to fix that as well. What I was trying to say before my mic died was that it's a good idea to make this unsigned simply because there's no such thing as a negative index in a vector, and that warning that I got when I compiled previously was just letting me know that, hey, you're comparing something that could be negative to something that can't, and I'm not comfortable with that. And then over here, I went ahead and added a call to that toString method just so that it would we'd actually get to see the fruits of our labor. And then I went ahead and ran make, and I go ahead and run, and you'll see that Susan Smith is enrolled in the following classes: English Lit. Okay, so there's our student and our person class, and you'll note that if I do call Susan.talk and have her say something like, hello, Fred, that when that runs, it's clearly using the same talk method as person. I haven't redefined that. So hopefully this gives you a better idea of what inheritance looks like. And do go ahead and send me questions. I'll try to answer those in a later cast of some form. All right, so now we're going to go ahead and close these out and move on to templates. So I'm going to go ahead and back out of the inheritance directory and move into templates. And this will be the same as the starter files you have. And what I'm going to do is actually say, okay, let's open up all of these in Genie. And one way I can do that is just type the word Genie and then open up. In this case, I want to say, okay, match everything that has a dot. So you'll note that here I've got 3 files that match blank dot something else. The make file won't match that. Notes, my folder for notes won't match that, and my folder for starters won't match that. But I can, so that's an easy way just to open up all the files I need. Then I hit enter, and we hop back over to Genie, and you'll see I have all of those. The make file is very, very similar to the previous thing. So we're going to talk about templates, and to do that in a way you haven't necessarily seen before, I've chosen to make my own imaginary data structure. So there actually isn't a data structure called box generally accepted. It does mimic the way another sort of data structure that you'll learn about later works, but I really just want to focus on how do we make a template. So this is a super, super simple data structure. Literally, I want you to think of a box. So a box of cereal, a box of cookies, whatever your favorite box filling item is. In this case, we have a box of integers. And you'll note that I have an integer to track the capacity of the box. How big can the box be? I have an integer for size, how many things are in the box, and I have a pointer that I'll later use as a dynamic array that represents the contents of a box. I also have a default box capacity to use just to make my life a little easier. And then next you'll note that I have a default constructor, an explicit constructor that takes initial capacity, a way to add items to the box, a way to remove them, and a method of resizing the box. Now, normal boxes of cookies can't be resized, but we have special boxes and they can. If I hop over here, you'll see by default constructor just says, all right, make the capacity, the size of the default capacity, set the size to 0, and go ahead and create set contents so that it points to an array of size default capacity. My explicit constructor is very similar. I have just noticed I have a typo. It doesn't really matter, as I've mentioned previously, but I'm going to go ahead and just fix this so that it's consistent, and I'll try to have that fixed in your starter file as well. So here I'm saying set my capacity to whatever the initial capacity specified by the user is. Again, the size starts at 0. Boxes don't start with things magically in them. And then the contents pointer ends up pointing to an array of size initial capacity. You'll see I have a way to add things where I first say, okay, if my size equals the capacity, I need to get bigger. I'm going to resize to double my initial capacity. And after that, I'm going to add something at spot size. So I'm going to take this thing and add it there. And then I'm going to increase size. Again, I've noticed that I'm working with some disjointed versions. So here I called it new item. And there's no reason why I can't do that here as well. I just want to make sure that I get all of these renamed. Next, I come to remove item. Here I'm saying, all right, if the size is greater than 0, go ahead and just decrease the size and return whatever was at the last spot in the array. Remember that since we start numbering our array indices at 0, that if I had a size of 5 and I say, okay, decrease the size and then return whatever's at size, I'm going to return what's at 4. Or what the previous size was, -1. So that lets me pretty easily and pretty neatly get the return value I want. However, if we have to assume that users are going to make mistakes and use what we're doing, or even just have logic errors when they're writing code. So what I do is I check and make sure the size is greater than 0, make sure there's something to remove. So I'm just going to make a note of that in my comments. So and then I go down here and say, okay, if there's nothing to return, if there's nothing to remove, throw an error. I won't get into the reasons behind what error to throw or how to do that, but just know that if you throw an error, that'll say, okay, that didn't work, stop what you're doing and stop the program, and I'll demonstrate what that looks like. And I just pass an error that hopefully communicates to my programmer exactly what went wrong. Namely, there was a logic error, there's nothing to remove from the box. Last is my resize, and here I say, okay, if take the new capacity. If the new capacity is different from the old capacity, go ahead and start resizing. There's no reason to do any of the work for resizing if the capacities are the same. And then I have some code down here saying, all right, let's go ahead and make a new array depending on size. I won't get into the logistics of exactly how this works either. You're welcome to dig into it and send me questions. This is really more a demo of how to make a template than it is of how to remove something from a dynamic array. Then here you'll see that the last thing I really just want to note is make sure you clean up after yourself. If you're coming from a Java background especially, C++ doesn't do any garbage collection for you, so you do need to make sure that you free up that memory that you were using, just, so you don't crash your computer or have problems later. Next, I'll go to Box Demo and make a little box. And I'll go ahead and show you what happens when you try to remove something that isn't there. So I'm going to go ahead and send remove item. And I'll go ahead, again, make sure you call that make command just like we did before. And we run, and you'll see it says terminate after throwing an instance of logic error, nothing to remove from the box, core dump. So say, you know what, you tried to do something wrong, stop that, quit immediately. And then here, let's see what it looks like if I say mybox.add, and I'll give it an integer so it has something to remove. Now, when I run, everything goes smoothly. You don't see anything because I didn't add anything for it to do. You'll note that my remove item method does return an integer, so one thing I can do here is say just see out that result so we can see what we got from the box. And you'll see we get that 42 right back out. So again, pretty simple data structure, not looking to be complicated or groundbreaking. You're never going to use this box for anything, but it is an easy way to demonstrate templates. And what I've tried to do up here is add some notes for how that works so that you can follow the steps on your own separately from the video if you want. So the first thing you want to do is copy everything from box.cxx. So I just Control-A, Control-C, and paste it in box.h. And one common mistake or problem is to end up getting rid of this endif. You really don't want to do that, so go ahead and make sure that you're above it before you Control-V and paste. And yes, you've made a mess. Congratulations, it's the first step to template greatness. The other thing I do next is comment out everything in box.cxx. Some people delete it or get rid of the file. I like to keep my old work as notes just in case something goes wrong and I need to try reverting to my old code. There are actually official ways to do that are much better. What I'm doing here is just one kind of hackish way to do it. The next thing you want to do is grab all your includes from where they're floating in the middle. You don't really want them there. You want to move them somewhere where it makes sense. So I'm just cutting and pasting up here, and then I want to get rid of that pound include box.h. That would be circular. I can't include, it's like saying put the box inside the box. You can't do that. So just make sure you get rid of it. Save frequently, because this next part is going to be a little bit messy. So here I have all these pieces pasted where they need to be. My next step is to start telling this thing, hey, you're a template now. And I do that like this. I can put any name I want right here. It's pretty common to see a single letter. It's pretty common to see all kinds of stuff. I personally prefer to call it what I see it as. And in this case, I see it as items going into the box. So that's how I do that. All right, so remember how I said you're going to be the copy and paste champion? Now copy this, and you want to paste it before every single method. I know, you're all super excited about this. You can do in more complicated editors than Geany. There are ways you can do this with regular expressions and copying and pasting a little more smartly, but we're just going to do it this way in Geany. All right, so next we want to tell our class that it's now not just a box, it's a box of something. In this case, a box of items. Just like when we had that vector before and we said you're a vector of strings, you're a vector of ints, we want to say you're a box of something. In this case, I really do recommend search and replace just so you don't miss any. In Geany, that's Control-H. There are a whole bunch of different search engines that have different versions. And what I want to say here is, okay, take anywhere where it says box : and replace that with box, angle bracket, item, close bracket. So you'll see this is our new type. We don't just have a box anymore, we have a box of generic items. Go ahead and say find, and then I'm just going to kind of go through and check these one by one. There's no reason why I couldn't say do that, take that action for all, but that's just the way I choose to do it. All right, you are almost done making your template. The last step is to find anywhere. We previously had a box of integers. Now what we want to do is say, all right, where should that be an item? So here are the contents of our box is an item. Down here we have an integer, and we don't want to change that because our initial capacity is still an int. Here we do want to say add a new item of type item. We do want to change that, and we want to change what we return for remove item. So just anywhere where an integer should be replaced, or whatever initial type you used, you want to just set that up. And this is the part where you have to turn your brain back on. With the copy and pasting part, it's sort of mindless, but here you want to just kind of be reading through your code and say, okay, where do I want to have an item instead? There are different schools of thought that would say you should write it as a template from the start. I prefer to do it a little more iteratively, and just to do it as you've seen me show you here. So this is not necessarily the most efficient way, but it is what works for me and helps me keep everything straight without making mistakes. So here down in resize, again, you'll see I'm making sure that I have everything of type item. Okay, so it looks like I've got everything. I'm going to go ahead and save and build, and you'll see I've got an error. That's actually something I should have expected. I didn't update anything over here. So here I want to say I have a box, and now I have to tell it you're a box of integers, not just a generic box. Oops, and I see, so that's what I was telling you about using find and replace. You can still get errors. So here I didn't get that angle bracket item in, and that's what it was upset about. So success. Make sure I'm in that box demo and go ahead and run, and you'll see everything works as it did before. So that's a successful template. One way to check and make sure everything is working nicely is just to change the type that you're holding. So there's my string. Again, build and run, and you'll see that everything is still working neatly. So hopefully this has given you an idea of how to use templates. You're welcome to ask questions or that sort of thing. And again, I've tried to include a generic version of the instructions up here for your reference. One thing I will note that just occurred to me is that it would have been better for me to say unsigned int for the capacity and the size, and to make those changes. I'm not going to go and re-record the entire demo just so that part can be fixed. But as I was saying before, if you can't have a negative size, if you can't have a negative capacity, it doesn't make sense for those things to be a regular int. It's better to use unsigned. So I'm just going to go ahead and kind of retcon that in, just so it, better code. Your starter file will be the same as mine, just so you aren't, so that when you're just now getting to this, you weren't confused when things were different on my screen from yours. Anyway, yeah, feel free to shoot me an email. My contact information is on Moodle if you need it, or via a message through however I end up posting this. And you're welcome to contact me, especially if you find mistakes or bugs or issues. I'd love to be able to fix those. So, yeah, hope to see you in one of my in-class lectures, and hopefully you found this helpful.